Next molecule we're going to do is not a molecule, it's actually a polyatomic ion. So we're going to do carbonate. Carbonate, because you know this because you memorized your polyatomic ions like a wonderful human being, is going to be CO3 2 minus. Now that 2 minus is going to influence the way that we get to draw this polyatomic ion molecule. All right. So carbon, that's got 4 valence electrons. You got oxygen, it has 6 valence electrons. There are 3 of them, so that makes 18 more. So, and then you've got this 2 minus. That means you have 2 extra electrons. So we've got 4 and 18 and our 2 extra, so that is 24 valence electrons to work with while I'm building. Oh, did I go off screen? I did. Okay. 24 valence electrons. Center is going to be carbon. And then we will bond each of the oxygens to that. That used up 6 of our 24, so we're at 18. Then we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and we're all out. Now, you might think, oh, it doesn't look so bad because we have oxygen with 8 electrons, oxygen with 8 electrons, oxygen with 8 electrons, but carbon is only touching 6 electrons, and that is a problem. And then you got to try and decide, well, I'm out of electrons, what do I do? You make a double bond. But should this oxygen make the double bond? Should this oxygen make the double bond? Should this oxygen make the double bond? And so we have a situation, this is called resonance for those of you who are interested. But for our class, what we will do is we will just pick the lucky oxygen. Which oxygen should it be? And I pick you, big fella. So you are going to take one of your lone pairs and share it with your buddy carbon. And so then we will, oh, the erasing, it's so ugly. Draw in the double bond, and there we go. A nice carbonate ion. Now with ions, you want to put it in a bracket and say 2 minus, just signaling that there are 2 extra electrons in here. Which 2? I don't know, don't really care, but there's 2 more than there had ought to be. Then if we're going to answer the questions about this, so Jeff Marks, if you watch this, I know you would disagree, but polar, non-polar, since there are no lone pairs around the central atom, we are going to go non-polar. It dissolves in water, but okay, just judging from the molecule, no lone pairs around the central atom. The fact that it's an ion, it'll dissolve in water. Then, what is the geometry? So we have 1, 2, 3 branches around the central atom. They are all bonds, and so this is going to be a trigonal geometry. And the bond angle on a trigonal is 120 degrees. And so that is your carbonate ion.